the one thing that we need to address is how this ontology for the IOF can be useful. And I've had some thoughts, and as you know, I've been involved in some grants which attempted to show how ontology could be useful to help optimization, cost optimization, for instance, and also some work on predictive maintenance using ontologies. But so what do you think are the main opportunities for getting value out of ontology?
I think we discussed in our previous work 4 areas where we can use ontologies. So for decision making, for data integration, I think one of them that actually can be useful is using ontologies and machine learning for real-time monitoring of manufacturing operations. I come in the broader sense. Again, not both manufacturing and operations is kind of loose term there. So if you have very often in automated machining, NC machining, they have something called adaptive machining, which means essentially that our processing parameters like cutting feeds and speeds are not constant during process. But what happens is that they are set initially to some value, but during the process, particularly if you have, for example, for avionics parts, you have very often, at least for traditional materials, aluminum as well, a large portions of materials being removed by milling. So the operation may last dozens of minutes. And so you can actually apply adaptive machining, meaning you start process with one set of parameters, you monitor health of your machine and tool during operations, so usually through sound or vibrations, temperature. You can also measure dimensions that are obtaining our parts. And as you monitor this, you may detect that a process is drifting out of bounds, out of tolerances. So you can apply adaptive learning to basically do real-time feedback closed-loop correction, so that actually, if, for example, if material becomes a little bit harder, you slow down your process in both feed or speed, so that you don't exceed forces in the process that would actually cause breakage to the tool.
And so the data could include, for instance, data about specific operators.
Could be operators, could be machines,
suppliers,
or petrol material suppliers. Yes, could be on processing parameters, feed and speed, which is important. Material, hardness, input hardness, nominal hardness, and real hardness.
And so my vision would be something like this: that we collect all of that data, we ensure that the data is tagged in a consistent way using ontology terms wherever possible, and then we use Sparkle query type analysis of the data, and then we can extract answers to queries such as, well, which is the factory which has the worst record of machine failure, or which has the worst record of quality deviation, and then we can use those kinds of data in order to see where we need to make.
Yeah, I believe that these two empty connect that I'm a little bit familiar, and Martin is going to familiar more, is a tool that allows collecting all these data during manufacturing operations real time.
Yeah.
And I think a benefit of ontology is that you said mapping to real-time data to input parameters and establishing correlation, if you will, between that.
But then the main benefit of ontology is that you get consistent vocabulary. You're describing the same phenomenon.
You are sure that you're getting correct data.
Yeah.
Incorrect.
Yeah. Or anyway, terminologically correct data.
Yeah. And then if you are mapping real-time performance and with the input parameters, if you collect enough data, you can send this to machine learning algorithm. Machine learning or deep learning or this.
I'm skeptical that we would, with such a multi-dimensional phenomenon.
Yeah, there is a many dimensions, so that's the other issue that machine learning still struggles, because it goes into higher number of dimensions of your problem, higher number of variables. You do have a problem, probably exponentially number of necessary training data to get reliable predictions from machine learning. But yes, I mean, it can go one as far as it goes. So potential cases, another that we discussed is um, key performance KPI is a term that says key performance indicator. Could be quality, could be productivity, could be uptime against downtime for machines. So you need to report them um, on time. And in this example we talked last week, they have every morning a shift meeting. So if you are lucky to get yesterday's data, you can actually react in real time for today's shift, use this data to improve your operation.
Okay, and they're already doing that.
They are doing that, but issue is that I believe that they want to have a consistent mechanism for presenting this data, so that actually understandable.
So my idea, and this was the reason why the IOF was originally introduced, is that if we have a good common industrial ontology across all of these domains, manufacturing, materials, design, and so forth, then we can create larger bodies of data, which may mean also bodies of data large enough to do machine learning,
Yeah.
not just within a given factory or even within its single enterprise, but across a whole branch of industry.
We could do that. I think ontology is.
So if we're going to be able to do that, we have to have something like a common ontology. For instance, if we have a multinational company, they're going to be using different languages in different parts of the company. I suppose they gravitate to English for when they're doing big data analysis. But there's still going to be differences. And if you have a large enterprise like the US Navy, then we already know that there are big terminological differences across different parts of the Navy, even in areas which are relevant to manufacturing or to maintenance, logistics,
logistics and maintenance.
So we already know that there is a potential for having an ontology serve a data aggregation support goal in a large enterprise like the Navy. But is that realistic?
So is it realistic that we collect data, or did we react on data?
So is it realistic to suppose, given the huge heterogeneity between different enterprises, that we could use an ontology to assemble very large bodies of data which would bring value? Now, I can think of certain sorts of value that they might bring. So if you're a federal government organization, you want to check for illegal manufacturing for dangerous manufacturing or for environmentally damaging manufacturing, then having large bodies of data which are cataloged in a consistent way using a controlled vocabulary, then that would be of value. But can you think of use cases which would actually benefit the manufacturing enterprises themselves?
Yes, the supply chain, automotive supply chain.
For instance,
car manufacturers, they have suppliers.
yes.
So if they have, if they use same vocabulary to interpret this data, what is uptime in one factory should be interpreted same as what is uptime in the other factory.
Yes, and that will then
enable them to make a rational and reliable decision in terms of, okay, how do we increase this uptime? So how do we invest in maintenance? So if you say your uptime in one factory, your uptime is 80%, in the other one is 75%. If they are using these different measures for that uptime on machines, we can say that 80% is better. But if they're using different algorithms or measurements, different data, I mean, this is calculated based on data collected on machines, how much machine is productive, how much it needs to be repaired or idle.
This actually is an area where I think ontology is already being used nearly everywhere, but people don't realize that it's an ontology that they're using because it's so small. So every time you have an algorithm, you specify the variables in the algorithm. And you can say, well, they're measured in meters, but what is the measurement of? For the algorithm to be applicable to uptime, then you have to specify what is being measured, what the measurement units correspond to. And that means
Yeah.
things like, well, uptime is the time when the machine is switched off, or uptime is the time when the machine is switched off for maintenance purposes rather than for normal scheduling and so on. There you're defining an ontology.
Definitely.
And then each enterprise is going to have maybe even the same algorithm, but it gets different results because the way the terms used to specify what is being measured are different.
Yes, giving
And the
different
ontology will
data.
give
Yeah,
you a way of capturing.
ontology is going to capture that. We capture
Yeah.
that in same mechanism, it is same way, same meaning. So
Yeah.
if you consider car manufacturing, it's the first tier suppliers and first tier suppliers, second tier suppliers, which are suppliers to first suppliers. If they have a consistent mechanism, you can say what is performance, and you can actually go ahead and properly address where you have to invest to improve performance.
Also, you can make decisions as to which supplier you should use.
Yes, yeah, if you do have, yes, yeah, definitely.
So I think